So picking up where we left off, here then is my precise definition of a limit. Okay, so it's saying this is true for any epsilon. Okay, so setting this, there is a corresponding delta such that this is true. Okay, the value of delta in the precise definition of a limit depends only on epsilon. Okay, so now let's talk about how you would do a proof. Okay, so this is on your little sheet of paper, these steps right here. But you need to remember your delta epsilon definition. Like you need to remember from here, we have this. Okay, so I'm basically going to take this word for word. We're going to state for each epsilon greater than 0, there exists a delta greater than 0 such that this is true. And we're going to use the given function limit when we write this. Then we're going to work with the first absolute value inequality and try to manipulate it so it looks like the delta inequality. This will give you a delta relation into epsilon, and then we're going to state our conclusion. Okay, so we're going to do that with the problem we have in example 4. So we're going to prove that this is true. Now, you know using direct substitution that the limit of 4x minus 15 as x approaches 4 is equal to 1, because that's a linear function. There's no holes. You know that that's the limit. But we're going to prove it to be true using our precise definition of the limit. So remember, that says the limit as x approaches a of f of x is equal to L if for any epsilon greater than 0, there is a corresponding delta greater than 0 such that this distance is true whenever this is true. Okay, so that's my definition. Okay, so we're going to go through those 3 steps on your little sheet. So we're going to start with number 1. So for each or for every, okay, for every epsilon greater than 0, there exists, which that you can write there exists as a backwards E if you want. There exists a delta greater than 0 such that f of x minus L, so my limit is 1, is less than epsilon whenever x minus 4 is less than delta. Okay. So now f of x I'm going to replace with my function. So I'm going to be working with 4x minus 15 minus 1 is less than epsilon. So I'm going to be working with this inequality, and I want it to somehow have an x minus 4 on the inside of the absolute value by itself. Okay, well that's not too hard to do. You have 4x, combine your like terms. Okay, the absolute value of 4 is just 4, so that can come out. And now divide both sides by 4. And this is the work that has to be done. You found this delta now in terms of epsilon. Okay. All right. So that was our main goal, and now we got to state our conclusion. So now, our given for any epsilon greater than 0, we can choose a delta equal to epsilon over 4. Okay, so I'm going to go, and so now we can assume that that's my epsilon. Okay. So that was this right here. Okay. And then I just do the work backwards. Okay. So the 0 piece is not necessary to have there, but if I want to multiply through by 4, okay, so now I'm going to work backwards. And the 0 you don't have to have. Okay, you can take it inside absolute value. Okay. So if this is true, so now we're assuming this, and now we're doing the proof part. So we're showing then that f of x minus L, that there exists a delta such that this inequality is true. And that should be our final, well, okay, so that's what we want. And then we say therefore the limit as x approaches 4 of 4x minus 5 is equal to 1. All right, so I know that seems redundant, and it is. It is. So step 2 is kind of our way to write epsilon in terms of, or write delta in terms of epsilon. So then when we find our delta, then we do the steps backwards to show that for any epsilon, we can find a delta such that that part is true. Okay, so on your test, you will have to do something like this on example 4. It's not going to be overly complicated, but you do have to memorize these steps. So use the 1, 2, 3 on the little sheet that I gave you to practice this, and you could pick anything to practice. You know, use any linear function and set up a limit that you know is true, and then practice going through the steps. We will talk about this also when I get back.